Today our problem is all about the Thevenin's theorem. Find out the current flowing through the 4 ohms by using the Thevenin's theorem is our problem. Here load is 4 ohms. Why? Because whatever the response is finding for that branch is the load. Here we are finding the current flowing through the 4 ohms. That is the load. In order to find out the current flowing through the any branch by using the Thevenin's theorem, we are following the 3 steps. In that, first step is remove RL. Here our load is 4 ohms. So first remove RL, that is 4 ohms, and find the voltage between load terminals. Here the load terminals are, these are the load terminals. So our target is to find out the load voltage between load terminals. So for step 1, our circuit is like this. I am repeating again. Here first step is remove RL, that is 4 ohms, and find the voltage between these two load terminals. So for first step in the Thevenin's theorem, we are finding the voltage across load terminals. Here our circuit is, after modification, our circuit is like this. Here our target is find the voltage between these two terminals. Clearly observe that here the terminals are open. So the current flowing through the 1 ohms is 0. So whatever the voltage across 3 ohms is nothing but VOC. Why? Because the current value is 0. So voltage across 2 ohms is 0. So whatever the voltage across 3 ohms is nothing but open circuit voltage. So we can neglect the 1 ohm resistor while finding the VTH. Why? Because here the terminals are open. So current flowing through the 1 ohms is 0. So voltage is also 0. So in order to find out the voltage across 3 ohms we are using voltage division rule. Voltage division rule is nothing but it is applicable only for series circuit. Why? Because voltage is divided for series circuit and current is same. Here the voltage across 3 ohms is find out by using voltage division. Voltage division rule formula is total voltage into that resistance by total resistance in the series circuit. That is, total voltage is 20. Whatever the voltage is finding, that resistance value is 3. So total voltage 20 into that resistance 3 by total resistance in the series circuit, that is 2 plus 3. So value is 20 into 3 by 3 plus 2. So total VT voltage across 3 ohms or VTH or VOC is 12 volts. And in the Thevenin's theorem, our next step is remove RL, that is remove the 4 ohms and find the resistance between these two terminals. That is, first remove the load, that is 4 ohms, find the RTH between these two terminals. That is our second step in Thevenin's theorem. While calculating RTH, whatever the sources present in the circuit are replaced with their internal resistance value. Here 20 volts voltage source internal resistance value is 0. So this 20 volts is short circuit. Then next you have to find out the RTH. I am repeating again. For finding RTH, first remove RL for the main circuit, and after removing the RL, again any sources in the circuit, those are replaced with their internal resistance value. For this circuit, we are having voltage source. So, we are replacing this voltage source with short circuit. If in case circuit consists of current source, we have to open that source. Next, we are finding the RTH between these two terminals. So, our calculation starts from the opposite side. Here, for this terminals, opposite side is we are having 2 ohms and 3 ohms are in parallel. That resultant in series with 1 ohms, that is the RTH. 2 ohms and 3 ohms are in parallel. That formula is 2 into 3 by 2 plus 2, that is R1 into R2 by R1 plus R2. Parallel resistance formula we are applying. Next, that resultant is in series with 1 ohms. So, resultant plus 1 ohms. Total RTH value is 11 by 5 ohms. So, second step is completed for Thevenin's theorem. Our first step is remove the RL, find VTH or VOC. Next, step 2 is remove the RL and find the RTH. While calculating RTH, sources are replaced with their internal resistance value. Step 3 for the Thevenin's theorem is draw the Thevenin's equivalent circuit, attach the load to the circuit. Thevenin's equivalent circuit is nothing but voltage source in series with resistance. This voltage source is value is getting from step 1. This resistance value RTH is value comes from this step 2. Whatever the values getting from step 1 and step 2 are, we are writing here. That those are VTH and RTH are in series. This is the Thevenin's equivalent circuit. For this circuit, we are attaching the load. What is our load? Load is 4 ohms. 4 ohms is attached to these terminals. Our final target is find out the current flowing through the 4 ohms. Here, voltage source in series with 2 resistors. So, what is the formula? VTH by RTH plus RL. General Ohm's law. I equal to V by R. Here, 2 resistors are in series. So, current equal VTH by RTH plus RL. After substituting, we are getting current flowing through the 4 ohms by using Thevenin's theorem is 60 by 31. Thank you.